All right, this is an air resistance problem, so I'm going to do it a little bit quicker. First thing, the ball's been released from rest. I'm just going to say this. Some people drew the force of air resistance going this way. Why? Gravity points down. The gravity force points straight down. And we're going to give it a length of 3 or 2. And then short time after the ball released, air resistance force is just a little bit shorter than gravity. Now, once we've reached terminal velocity, the forces balance. Okay, so here's the air resistance force. Sorry, I'll call it FR the way they do. They should be equal length. I saw people not draw an FR when terminal velocity had been reached. I am not happy with you. All right. So the forces balance. FR equals FG. So we have here this force negative BAV equals mg. That's just this. Copy it. And then isolate V terminal. And you're just going to get V terminal is, just keep the sign consistent, mg over BA equals V terminal. That seemed to be an insurmountable challenge for a lot of you. Kind of like my ability to pronounce the word insurmountable seems to be an insurmountable challenge. All right, so we want to now get the time to reach 1/3 of terminal velocity. So we got to integrate mg minus BA. V equals m dv dt. Let's do some integration. So mg minus BAV times dt equals m dv. Let's do a u sub. Yeah, why not? Why am I doing any of this? Oh, that's right. dt over m. That seemed a bit, that's a bit of an extreme statement. All right, so there we go. We're going to integrate both sides here. Let's do a u sub. Really excited. Here we go. U equals mg minus BAV. So du is negative BA times dv. So negative du over BA is dv. Let's do some substitution back into here. So we're going to get dt over m equals, and now our integral is going to change up a little bit. We'll have a little negative sign here. I'm going to just pull some things out of the parentheses. So we're going to actually have here negative 1 over BA du over u. Let's multiply both sides. Let's get some stuff simplified. So we're going to have negative BA over m dt integrated equals du over u integrated. And of course, when we integrate, we're going to get negative BA over m times t equals the natural log of u plus c. We need to isolate c. So at 0, v0, so we're going to say negative BA over m times 0 equals the natural log of mg minus 0 plus c. c equals natural log of mg. And so let's go ahead and we'll actually solve negative BA over mt equals natural log of mg. So c is negative log of that. So we get mg minus BAV, and then we divide over mg. We take e of both sides. And so when we isolate v, by the way, what we're going to end up getting is v is BA over m1 minus e to the negative. Sorry, I don't have this right. V is mg over BA. It's the terminal speed. 1 minus e to the negative b a t over m. Now, we want to reach 1/3 of terminal velocity. So we're going to actually get to mg over 3BA equals mg over BA, 1 minus e to the negative BAT over m. We want to know when that happens. So we're going to end up getting, let's isolate a little bit here, we're going to get negative 2/3 because there's going to be a lot of cancellation here, equals e to the negative BAT over m. We take the natural log of both sides. So negative the natural log of 2/3 equals BAT over m. So we have negative m over ba natural log of 3/2 equals t. Sorry, 2/3. 2/3, okay? So that's what we end up getting here, negative m over ba, natural log of 2, yep, that's it. So that's the time we're looking for. All right, right here we get the acceleration and the velocity. So let's remember, we start off with an acceleration of g, and then it decays. And then here the terminal velocity graph is going to be mg over ba. So we start off here, and then we eventually level off to this terminal speed. I was a little disappointed to see so many errors on this, so we got to tighten that up a little bit. All right, so that is the first free response question.